Now, we're looking now again to the centroid of a plane area. What do you mean by a centroid? Um, it's instead of just looking for the area, sometimes we're also, or most of the time, we're also be interested in finding for its centroid. What do you mean by that? Why are we looking for the centroid in the first place? So, for example, let's have this figure. Um, let's have a general figure that looks like this. The curve, that's the upper curve, and shall we say that's the lower curve, okay? And the area is between that two curves, the blue and the green curve. We're trying to find, well, we're able to get the area, right? How do we get the area here? Area is equal to x1, y1, and here is x2, y2. How do you find the area again here? Area will just be equal to the integral of y upper minus y lower. Y upper here is y blue minus y green, right? Follow? Times dx from x1 to x2. Well, area is just easy to find the area. Well, we'll be able to get a value, but now the centroid is also another thing. Centroid is, especially for civil engineering and for the rest of, you wanna be interested also where will you what? If this is placed, this figure, flat figure, placed horizontally, where will you what? Where will you put a certain point to support that it will balance? Okay, meaning the whole figure must balance. We're looking for xc, yc. You follow? That's the centroid. Meaning if you put it flat and then you put a like a pin or a what? A rod in the center, it should balance. Okay? So we must be able to know that because it's important, right? We want to support things at their centroid so that it will be a lot stable. Because if you support it here, most likely it will topple over, right? So that's the idea. Finding the centroid is a very important thing, especially if you want to do balancing or statics, like creating something that will just be balanced. Now, how do we do that? Well, it's difficult to get the centroid of a big thing. Because what the figure is complex. However, if we look into the what if we look into the vertical strip that we're trying to make, okay, look at the verticals. I'm trying to make it look bigger, so it will not be difficult for us to what is it. The area is for sure dA, right? The area of this strip is dA. It's a given. The thickness is dy. Now, what is the centroid of this coordinate? Where do you think it is located into this in this figure? This is a rectangle. It's easy to find the centroid of a rectangle. Okay, here it's very thin. The x coordinate of the centroid must be what? The x, right? What is the x for that? Okay, that's the x coordinate of the centroid. So this coordinate must be x. How about its what? Y coordinate. It must be the midpoint between the y upper and y lower. Do you follow? So the y coordinate will be what? It must be y upper plus y lower over 2. Do you follow? That's the what? That's the centroid of this small figure here, right? This is the centroid of this whole figure, this small figure. Do you follow? Now, the thing is that what we can do is we can do moment, finding the moment of this, meaning the moment with respect to the y-axis, okay, the moment of this area with respect to the y-axis is equal to the area, okay, times how far is the centroid from the, you follow, area times how far the centroid from the y-axis, okay. Let's do what? Moment of an area with respect to y-axis. What is that? That small thing. What's the moment with that small thing? Area dA times how far is this from the x-axis? From the y-axis, I mean. X, right? It will be x. X dA. Do you follow? It is x dA And if we sum all of that, if we sum all the moments, they follow? If we sum all of that moments, that will sum up supposed to be the what? The big area times the big centroid. They follow? So meaning the sum of all of these small moments of an area was supposed to be equal to the total area times the location of its centroid. Okay? That's why we're able to solve for xc. Okay? So in this case, if we're doing vertical strips, this will just be eventually, what is xc for this? The coordinate of the centroid, the x coordinate of the centroid will just be integral of x dA, right? Over a. And what is x dA on the first place? dA is just this thing, right? This is dA. Y upper minus y lower times dx, right? Times x. So as simple as that. The integral of x times y upper minus y lower dx over this one, the area. I think I suggest you separate, you solve for the area separately in the beginning. This is what? Getting the what? xc, the x component. Now, how about if we're looking for what? The y coordinate of the centroid. Well, we get moment with respect to the x-axis, okay? Moment with respect to the x-axis, moment of an area with respect to x-axis, and that will be, this is what will happen. That small area is dA. How far is the center of this area from the what? From the x-axis? Simply the coordinate of the y coordinate of this one, which is y upper plus y lower over 2. Do you follow? Okay? Meaning what? The what? The centroid. It's not just as x, it's what? Y upper plus y lower over 2. Okay? The midpoint. The midpoint. And if you integrate that, that is just the same as the big YC, okay, times the total area A, and therefore YC will just be equal to this thing divided by what area. Now it looks complex at that. Let us see some problem to fix. Okay, let's see some problem. Determine the abscissa of the centroid of the area bounded by the parabola y squared equals 4x and the line y is equal to 4. Now take a look at this. Parabola, right? Y squared is equal to 4x. What's the vertex here? 0, 0. Opens to what? Upward or downward? To the right, okay? None of these. So it must be opening to the right, and the line y equals 4. Where's line equals 4? Let me draw, oh, no. Let me draw line y equals 4. Where's that? 2, 3, 4. It must be this line, right? Do it in green. Okay? Y equals 4. So the parabola will look like center of the area bounded by the parabola, the line y equals 4, and the line x equals 0. Where's the line x equals 0? The what? The y-axis, right? Is the line x equals 0. Okay? And the curve y squared equals 4x. Is it to the right or to the left? Vertex at 0, 0? Yes. Vertex at 0, 0 to the right. Okay? How will I draw that? Like this. Okay? Right? Where will it cross? So well, let's now. This means what? 4 squared is equal to, it's intersection between these two curves. Y squared equals 4x and y equals 4. 4 squared equals 4x. Therefore, x equals 4. This must be 4, 4. Okay? 1, 2, 3, 4. Okay? So that point is 0.44. So where's our region here? The region must be this one in blue. Okay? This must be the region. That's the only thing bounded by the three curves. The lower is the what? The right is the line at x equals 0, and this one is y equals to 4. Okay. Now, of course, to find the centroid, we must find first the area. Okay. So this one is really good what? Good practice for finding the area. How do you find the area again? What strips will you use? Vertical or horizontal? Vertical is good. Okay. Really? Well, okay, let's use vertical for the sake of we want to use vertical. So vertical strips, so it will be happy. Okay. DA, that small thing, DA, the area of this rectangular strip, the height is what? Y upper, Y upper minus Y lower, the green one, times the thickness, DA, dx, right? The thickness, dx. So area is equal to, what is Y upper? This one, 4, good. What is Y lower? No, note that, okay, note that when we solve for y for this case, we have, okay, we start with y squared equals 4x. This will tend to be y is equal to positive negative square root of 4x. And actually, it's the 2. The y is equal to positive minus, plus 2 square root of x. This is the upper one. Okay, this one, y is equal to minus 2 square root of x. Do you follow? That thing. That turns out to be the two forms. The lower curve, so meaning these two curves are different if we solve for y, okay? But of course, if we draw a horizontal strip, it should not be a problem, okay? We will not have that problem in breaking down the y because here, clearly, x is just y squared over 4. But anyway, we already done that. So 4 is minus what? 2 square root of x, okay? dx. From where? 0 to 4. So what's the area? Let's okay, so let's thank the calculator for all the what? The good things that it has given us. No, not that. Um 4 minus 2 square root of alpha x. Be sure you know how to type fast. Okay. Lower limit 0, upper limit 4. So what's the area? 5.33. Okay. 5.333, the area. Do you follow? Now, if the area is 5.333, um, so now how do we find out the centroid? Well, we're only being asked for the what? The abscissa, meaning the x coordinate only. Okay. Now, if we're looking for the x coordinate of the centroid, what's the centroid here for this figure? Just the x, right? That the centroid of that small figure. Let me look at it. The centroid of that small figure. Let me just bring it down. Is what? X, and the area of this small figure is dA. I'm trying to get the moment of this what? Of this area with respect to the y-axis times dA, okay? And if I sum all of those, it's equivalent to the big area times the x coordinate of the centroid of that big area. Do you follow? Xc times A. So now I'll be glad to solve for Xc. I'm trying to derive because it's not all the time that it's good to just memorize things. X dA over what? Over A. We know A already, so not a big problem. So what X here? What's dA? dA is this, right? 4 minus 2 square root of x dx, right? That's the dA. Y upper minus y lower dx. So from where? From 0 to 4. So let us see, over A. So what will that numerator be? Let's do that. Integrate. So we just have what? We just add here the what? A what? An x, right? You follow? It will be like that. That gives me what? The numerator is 32 over 5. 32 over 5. Denominator is 5.33. So if I divide by 5.33, I'm getting a 1.2. Option C. You follow? That's the x coordinate of the centroid. Meaning how far? How far is the centroid? it's it's 1.2, meaning at x equal to 1.2. Take a look at this. Where's 1.2? One. I think this is the proper one. Never mind that. 2, 3, and 4. So 1.2 is somewhere here. Do you follow? 1.2. This is the centroid, right? I think it's good. However, if you are fine with shortcuts, this can really be done without solving much. Okay. The centroid of a what? Of a region bounded by a parabola, assuming one is the vertex here, will just turn out to be what? Do you have an idea? Will be what? For a what? I think you're familiar with this. For a triangle. How about for a triangle? For a triangle, what's the centroid? For example, if I have a triangle like this, where's the centroid? It should be what? One third from from this from that one with the right angle. Okay, it must be one third. For this one, I think it must be what? One fourth. I think it's one fourth. No. How long is this again? One third. Same thing. One third. What is one third of four? No, it's not. Right? No, never mind. Never mind those. But the thing is, what if we're being asked also what is the what? Of course, they only ask for xc, so we're happy to say that this is xc 1.2. What if they're asking for? What do you think? The yc. So what is yc here? This figure. We need to know that. At least we can do that in practice. So yc for this figure, what's the y? So I'm now trying to do moments with respect to the x-axis. So meaning, that area is dA, that blue area dA. How far is it? How far is that centroid from the x-axis? It's simply the y-coordinate of the centroid. Now, what's the y-coordinate of the centroid? That's the midpoint between these two values, okay? Y upper, which is 4, plus y lower, which is, no, midpoint is y1 plus y2 over 2. We don't subtract them, okay? Square root, no. 2 square root of x, right? Over 2. So that's the what? That's the coordinate of, that's how far is this point from the x-axis. You follow? If I integrate that, sum all of that, it's the same as the whole area times the y-coordinate of my total centroid of the area, of the big area, right? So from here, it is clear, I think, that, so what's this value first? Okay, let's evaluate that. What is dA? This is 4 plus 2 squared of x. What is dA? Over 2. dA is 4 minus 2 square root of x. So never mind simplifying. Anyway, it's the calculator's job to do this, okay? Do you follow? Anyway, it's the calculator that will be doing it. From where? From 0 to 4. So if we let the calculator do the hard work, wait, let's see. 4 plus 2 square root of. Are you tired? No. That's good. Over what? Over 2 times what? 4 minus 2 square root of x. You don't need to simplify because we're so happy that the calculator can do this for us. From 0 to 4, okay? And it gives me 16. Now, can you just guess first? YC times say 16. What do you think is the centroid location here for the y? Around 3? Somehow here, most likely 1, 2, 3. Let us see. YC times A is 5.33. So YC is what? 16 over A, which is 5.333. Let us see, what's that? Divide 5.333. That's what? Oh, amazing, right? That's at 3. Okay? I think it still works with like it's now one fourth. It's now one fourth for a parabola. It's now one fourth of the of the distance from the what? From here. And it's, I think, I forgot the exact. No, there's that. If you study now statics, you will see some special formula for what? Shortcuts for where to locate the centroid of figures, like an area bounded by a parabola and a line. What is the centroid of a figure? Okay, you'll be able to learn that. I think this one is a good discussion. Thank you.